Over to you, Paul.
Good morning, everyone. Thank you, Manoir. Good morning, everyone. Welcome to the third of the sequences of webinars on emerging technology hosted by University of Glasgow and Satellite Applications Catapult. And the approach for these webinars is really to bring together people with a really strong interest, not only in space, but the particular topics that we think are going to be of most interest. And today we're going to be covering space sustainability for the next century. So really, I think this is a very topical subject and the one that has garnered a lot of attention because of the activity that's taking place. And we have a number of speakers today. We're splitting this session into two blocks with a break in the middle. And I'll introduce the speakers shortly. Unfortunately, we haven't got our colleague from UK Space Agency, Tammy, who's unwell today. So I'm going to just set a bit of context on their behalf. And so I'll just share my screen to show why we think that really this is garnering so much interest. So Manoir, if I could take control. Thank you. So one of the consideration we'll all be very familiar with at the moment is it doesn't really matter where you look in terms of the services that we deliver from space, whether they be for position, navigation and timing, which has historically been constellations in the medium Earth orbit, or for observation, typically in low Earth orbit and geostationary orbit. But one of the main interests now is constellations of satellites which can provide ubiquitous coverage or very sophisticated combination of sensors, or for communications. For instance, the low Earth orbit constellations now for broadband connectivity. All of these satellites are really coming together now as constellations, and that brings together real opportunities in terms of providing capabilities. But these constellations, this proliferation of constellations, not only provides, it's necessary to provide these services, whether they be 100 megabits per second per user, 10 centimeter positioning and 25 centimeter or better resolution services for Earth observation. Really, these are being driven by the demand for autonomy in the transport networks, the digital transformation of businesses. But it also means that in the future, we won't be able to manage these constellations of satellites in the way that we've done them in the past. There will be literally thousands of satellites that need to be monitored and supported by artificial intelligence mechanisms and maintained and in space. And that whole industry of the economy of space is likely to change over the next few years to be very much more highly automated to make sure that the businesses can be sustainable. And I think one of the fascinating things looking out to beyond 2030 is all of that capability for managing and modifying and upgrading infrastructure in space. That means that we can anticipate future very large structures being created, being assembled in space for things like manufacturing or space-based energy generation, or even tourism in the future. And in order for this new economy of space to become a reality, we absolutely have to make sure that space is sustainable. So today, I'm going to stop sharing. We're going to introduce our speakers for this morning's session, and they'll give you their perspective on the things that they need to be done and the things that they're doing and working towards making space sustainable for the next century. So I'll stop sharing now and hand over to our first speaker of the day, who is Maurizio Vanotti, who's VP of Space Infrastructure and Partnerships at OneWeb. And one of the things that is that the community is animated around the science community are things like making sure that science can continue. So over to you, Maurizio. What do we need to do to make sure that space is sustainable, your business is sustainable, and science can continue?
Thank you, Paul. Good morning, everyone. So I will start sharing my deck. Give me 1 second. You see the slide deck?
Yes, it's not in presenter view just yet.
Can you see it now?
Perfect, thank you.
Perfect. How do I hide this? Okay, so it's not a deck by PowerPoint. It's literally one slide, 2 slides from my side. So OneWeb obviously is particularly close to the challenges of responsible space as we launch and operate a large constellation. So our generation 1 is going to be 648 satellites. So we are among the first few that actually is encountering these kind of challenges. And responsible space is part of one of our mantras. So it's something that we live and breathe on a day-by-day basis. It was actually one of the foundations, the elements of the vision over which OneWeb has been founded, and the idea of living no trace in space and acting responsibly. So we are a recognized leader in environmental, social, and governance criteria. There are essentially three for people that are not accustomed to them. So we're talking about environmental criteria, social, and governance. So regarding environmental, so it's about considering how company performs and the stewardship that they implement as part of their day-to-day business. From a social perspective criteria, it's about examining relationship with not only employees but also the supply chain and giving back to communities. And then governance, right, which is about leadership, internal controls, and auditors. But the more pragmatic, with a more pragmatic approach, and this is the summary slide. This is what we talk when we talk about responsible space. Essentially, we look at it in we split in 6 different areas. So this space situational awareness, space traffic management, ADR, RF interface, radio astronomy, brightest optical astronomy, and carbon footprint. And we are actively involved in every one of them. So starting from space situational awareness, our view is that constellation should not overlap in altitude. We are operating at 1,200 kilometers. It's a very, very stable and uncongested orbit. And our constellation is shaped in a way that is inherently safe. What does that mean is that our 12 orbital planes of the polar constellations are actually interspace 4 kilometers between each other, which means that when they actually converge towards the pole, there's no physical crossing of these wagons of satellites that are flying around the Earth. We're really pushing hard around reliability, for launches, and reliability for satellites, the way how satellites are designed, which actually is a key parameter to ensure that one of the key parameters that we use to ensure the constellation is operated safely. We are strong advocates about the introduction of a propulsion system for every satellite that is launched for orbits higher than 400 kilometers. And this is something that we've been very, very vocal about in many forums. And this is about space situational awareness. Transitioning into space traffic management, the essence here is that coordination is key. Coordination between responsible operators, and we are actively engaged with with our fellow constellation operators, namely Starlink. At the moment, it's just 2 big constellations that are up there. It's OneWeb and Starlink, and we have constant dialogue. So cooperation and transparency in that regard is key. We're also helping to develop new kind of traffic rules or traffic guidance, what we call right of way, similar to what's happening in the maritime world. But again, the word here is communication, transparency, and coordination. Regarding ADR is really in terms of in-orbit servicing is really uncharted territory. From our perspective, our position is that we should really foster diversity of a variety of different solutions that can be applied to different use cases. So we want to support the ecosystem, avoiding monopolistic scenarios. And also what is important for these uncharted territories, not only uncharted from a technical perspective, but also from a commercial perspective, right? And what are the kind of deals and the service contracts that would actually work, both for the service provider and the operator. So this is a dialogue that we actually have started with multiple service providers. Going to the practicalities of how do we actually coexist with other communities. So space is a natural common resource that actually also affects who's working on ground on Earth. So obviously radio astronomy and optical astronomy, so telescope pointing upwards. Talking about radio astronomy, astronomers are using bands that are adjacent to our Ku band spectrum, and in order to respect the area of non-interference, we have the first channel of our spectrum, allocated spectrum, which is unused in order to create this almost physical separation and coexist in the best way possible. Regarding brightness, we are actively involved in several working groups, the Dark and Quiet Skies and the SATCON2 conference, helping with other fellow constellation operators, to draft guidelines for industry, for the astronomers, with the astronomers, all together, in a dialogue that I have to say has been extremely constructive. People coming with different views, and this is great, because if we all had the same view, that would be concerning, but in a very constructive and productive way. So our satellites are targeting, there's a formula that has been put together by these working groups, this community, that normalizes the brightness at 550 kilometers and then creates the target brightness for the various altitudes. At our altitude we have a target of 7.8 magnitude, but what does it mean in practice? So two things. What are we doing in practice? So we are doing two key things. The first thing is that we are conducting observation campaigns to our generation 1 satellites in order to measure the brightness, the magnitude, and determine the footprint that our satellites once on station have. But then what we're going to do with these data? We're going to use this data to correlate a mathematical model that matches the prediction of the brightness, the magnitude observed in the sky from our satellite, and we're going to use this model in order to determine the brightness of the future generation for the next design, the generation 2 design of our constellation, in such a way that once we have the correlated model, the model can be used to tweak the shape of the satellite and assess in real time the impact that the satellite will have in the sky in terms of magnitude and brightness. Last but not least is carbon footprint. So we have an ongoing internal program that is evaluating, allow me to say, measuring the carbon footprint that we produce as OneWeb through our supply chain. Obviously, difficult for the rockets to be carbon neutral for the launcher, but we are introducing guidelines, not requirements at this stage, guidelines for our supply chain in the release of the RFI for generation 2, just to stress how important it is for us to be as carbon neutral as possible. So this is in a nutshell our view, what we are doing, and just as confirmation that we are as active as ever in this domain, which is not a PR, just a pure PR exercise from our perspective, but it's something that is real. It's something that's going to go into the requirements and the guidelines for the generation 2 RFI. And I think giving you some examples, both on ADR, on what we're doing to implement these radio astronomy, optical astronomy, and carbon footprint, and also the space traffic management, the coordination. Just give you a flavor that is not just some fluffy words, but it's something that we are doing for real. Thank you. I'll hand it over back to you, Paul.
Thank you, Maurizio. That's really good. And we'll have a proper question and answer session on the panel shortly, but maybe we just food for thought for the questions. Please, could everyone put the questions that they would like to see raised in the Q&A session rather than the chat session, and then that'll be easier for me to work through. But Maurizio, just one thought, really, I mean, maybe to think about, especially with this community. There is obviously some networks, some knowledge networks in the UK, like the Gnosis network, STFC knowledge network on space sustainability. But internationally, I mean, OneWeb, of course, has a global presence. Any thoughts about what we might need to do to make sure that you're well connected with that global research community?
I mean, we are connected with the Gnosis, for instance. I think that the connections, the links are there. Is about making sure that we talk the talk and walk the walk, right? Which is what we are trying to do, and we go above and beyond the nice white papers, but we do implement what we say that we want to do. And this reason why we launch the brightness measurement program, and if you just measure the brightness and you stop there, well, it has little sense, right? So the idea of then introducing the correlation model, and then we will use to drive the design for the next generation and do something for real with those measurements. This is what is important, right? And this also, what other fellow constellation operators have been doing. And then we can all argue that the level of success that has been achieved or will be achieved in the future. But what is really key is to act, right, rather than just react. The other element, right, is if you look at these 6 categories, the last thing that operators want is to be controlled, to be told what to do. So it's very, very human reaction, and the best way actually is to be proactive in that regard. I said, because we're living in a new era for space. 10 years ago, who would have imagined that would have hundreds of satellites, potentially thousands of satellites, just a few operators orbiting the Earth. So we are absolutely have to deal with a new variety of challenges, of issues. So the best way is to help to shape these kind of regulated environment in a proactive way. When the first cars hit the roads alongside horses, there were no traffic lights, and then as the traffic light as the traffic increased, new rules had to be written. Obviously, you cannot brake and accelerate and restart in space. There are no traffic lights, but the concept here is we need to, as operators, responsible operators, to proactively engage without waiting for the regulators that sometimes are disconnected with the reality of the problematics of what being an operator means. That's the point. I could go on forever, but
yeah, no, it's fine. I just want to say, so I'm sure there's lots of, there's a good research community here that's interested in participating. So maybe we'll get some thoughts in the session. But thank you, Maurizio. So now if I could hand over to Professor Massimiliano Vasile today from University of Strathclyde, who's going to look into the future of space safety and sustainability. So Massimiliano, would you like to share your presentation?
Yes. If someone gives me access to the video.
Okay. I think you should be able to share the screen now.
Okay, I'll try. Okay.
Thank you. And if you could just briefly introduce yourself as well.
Okay, good morning, everyone. So my name is Max Basile. I'm the director of the Aerospace Center of Excellence at the University of Strathclyde. I'm professor of space systems engineering, and I'm going to tell you something about what we do on space safety and sustainability. This presentation is together with my postdoc, Andrew Wilson, who worked with me for his PhD on space sustainability specifically. So there are three major points that I'm going to cover in this presentation. One is what I call the space sustainability paradox that I will explain in a minute. Then I will show a bit of what we do on space safety and environment management. And then how we go from space safety to what is now known as the space sustainability rating. So the space sustainability paradox for me is that a lot of people are looking at space as a way to be more sustainable, but they tend to forget about the sustainability of space itself. And in fact, if you look at what is happening in Earth observation, there are tens of missions and more people launch satellites to say be more sustainable on Earth and use Earth observation to do that. But Earth observation for sustainable development means space debris, because this means that we increase the population in space and space traffic becomes more and more complicated. Now, the general solution is to dispose of these objects or to find a way to make them re-enter or move them to a graveyard orbit. But if you look at this recent paper, disposing is not necessarily the solution. And it's a bit like what happened on Earth. We started dumping our trash somewhere, and then we realized that that was not sustainable. And we had to find a different way to dispose of our trash. And this because, I mean, even the disposal itself creates a problem of sustainability. But it's not just that. I mean, the whole space sector is, as a country, if you compare the space sector to a country, is producing a lot of pollutants, not just when you launch something or when you re-enter something, but during the entire life cycle. So these are analyses that Andrew did, and you can see that in the future, if we increase the number of launches as we expect, the entire industry will become a significant contributor to the carbon footprint. So the paradox for me is that the more we try to be sustainable using space, the more we become unsustainable because the use of space becomes unsustainable. And the economic growth has as a consequence that we reduce the sustainability of the use of space. And in particular, the private sector and every new launch coming from the private sector is contributing to that. So what do we do? So first of all, there are different things that needs to be done in terms of space safety and the management of the space environment. I listed some of them. Okay, tracking, environmental modeling to understand the evolution of the space environment, space traffic management, design for demise, active debris removal. And the last point is what I see as the future, and is recycling and in-orbit manufacturing construction. So at Strathclyde, first of all, we are leading a very large network called Stardust that in fact is the continuation of a previous network that is tackling problems in space safety and sustainability. We have now over 24 partners worldwide. And connected to that, we have a lot of projects with ESA and UK Space Agency, all focused on space sustainability that go from active debris removal to in-orbit constructions to re-entry. And as part of this, we are trying to develop new models, for example, to capture the actual complexity of what is happening in space, because more and more actors are there, and looking only at your own satellite is not really the solution. We need to look at the relationships between all objects in space. So current models have a very simple representation of this relationship as a sort of mesh But in fact, we expect that there are more complex relationships between objects in space or groups of objects in space that can be captured with some network theoretic models. But then there is also the need of automation because of the increase in traffic. We need to coordinate a lot of the maneuvers and the analysis of conjunctions in orbit. So we are developing also AI system to help operators to deal with this problem. And all this is integrated into a framework that we call Cassandra, that we are currently developing, that is putting together a lot of elements of space traffic management, space debris remediation, and connects to another element, which is designed for demise and re-entry analysis, which is implemented in another one of our tools called Foster. But as I said, that is not necessarily the future. The future is probably to do things differently in orbit, so design differently our spacecraft to be operated in the sense of being built, repaired, and replaced in orbit, reducing the need for transferring them to a greater orbit or make them re-enter into the atmosphere and then creating an additional problem in terms of environment management. So we have two projects now with ESA. One is on collaborative robotics to do in-orbit construction, replacement, recycling of modular infrastructures. And the other one is how to reuse elements in orbit to manufacture and remanufacture components without the need to launch more stuff from Earth. But that's not probably enough. So we are looking also at the sustainability of space as a whole, not just what happens in space, but also what happens on ground when you try to start a new program. And this connects to the current effort to define a space sustainability rating. So we have developed our own tool for life cycle sustainability assessment that includes also elements of what happens in space, also elements of debris mitigation or re-entry, pollution or pollution due to re-entry. But this tool covers the entire life cycle, so from conception to launch and disposal, and includes different elements to see what is the global environmental impact of a space activity. And some of the analyses that I showed before about the carbon footprint of the space sector were derived with this tool. This tool was validated against some of the tools that ESA has. So we are fairly confident that what we can produce in terms of analysis is consistent. And we integrated that with our concurrent design facility to experiment with this idea of eco-design. Eco-design is one of the elements of the ESA program, Clean Space. And essentially the idea here is to integrate elements of life cycle sustainability assessment during the design process so that whatever is designed has already this element of sustainability embedded into the design. And from there, the next step is to incorporate this element of life cycle sustainability within the definition of the space sustainability rating. Because it's not just about what happens in space, it's also about what happens during the lifetime of a space mission. And so we are trying to bring the two things together, so to have the space safety and environment management element connected to the sustainability of the development of the space mission into a single way to assess the sustainability of space. And that's me.
Thank you very much, Professor. That was you've covered a massive topic, range of topics here. This is really going to be stimulating some questions. We don't have much time for one, but I think I think your observation with regard to the linkage with this SDGs and the potential benefits that we get from bringing space to communities, we also need to consider. I think if we were to look at GNSS constellations, for instance, and the potential efficiencies that we gather on a planetary scale in terms of reduction in carbon footprint, I think we probably find that we have a net negative carbon effect if we look at it from those perspectives. So I do like the total life cycle perspective, and maybe we can come back to that in the panel. So thank you for your presentation. Very interesting. Just in the interest of time, we'll go on. So Victoria Irwin, head of business at SSTL, is going to present some of the technologies that actually might be imperative to get under controls for these to achieve the sustainability goals. So Victoria, over to you.
Hello there. Okay, I'm just starting to share my screen. Hopefully you can see it now.
Perfect, thank you.
Perfect. So good morning, everybody. It's my pleasure to be with you here with you this morning. As Paul says, I'm going to talk a little bit around some of the technologies that are needed to follow on in this area, what's been done in the past and what we're looking at going forwards into the future and the areas that we need these developments. So just to give you a brief idea, obviously building on what's been said before, we're all seeing that the number of satellites, objects being launched into the space environment is increasing significantly from previous years gone by. And just some stats here that show you and give you an idea of the size of the change over the last sort of 10 years, really, particularly in the microsat area. Now, as an industry, we have a global obligation to consider the space safe and sustainable use of space. It's one of the things that's garnering a lot of public interest at the moment, and the natural reaction of some is to stop using it, stop launching the satellites. You know, it's getting too congested, it's dangerous. We don't see it that way. We don't have to take the cars off the road. We've just got to make sure that they're safe in their lanes and that we can exit them at the right point. And we can use that analogy, as Maurizio sort of said, following on from how we used to use the roads in the past. We just need to look at how we standardize going forward. Now, the UK has been leading this initiative over the last few years and has done a number of things in this area that I'm going to touch on. And I'm encouraged by the enthusiasm we've had on recent calls across the industry to work together and try and solve this problem. And particularly, we welcome the National Space Strategy and the lines that have been put in there that acknowledges this issue and focuses some effort in these areas for sustainable use. So previously, what's the UK done in the past? So 3 sort of notable missions. Back in 2014, we had TechDemoSat-1, which I was personally involved in. It had on it one of the first deorbit sails that was ever launched. It also included environmental monitoring equipment. So though the TechDemoSat sail was not the first to be deployed, it was one of the few that had actually been stowed in the space environment for 5 years and then deployed, similar to how it would be on an operational mission. So we continue to track TechDemoSat. It's deorbiting now slowly over time, and it's providing us useful data to understand how that sort of deorbit technology works. Likewise, in 2017, there was InflateSail, a similar technology attached to a CubeSat, which I believe was one of the first deorbit sails to actually be deployed in orbit. It took just 72 days to come down and re-enter in its orbit. And then one of the more notable missions back in 2018 with our colleagues at the sort of Surrey Space Centre, and I should add that they were involved in the InflateSail as well, that wasn't SSTL, we had the Remove Debris mission. So that was another UK-led mission highlighting sort of the technology that could be useful in this field. It was launched from the International Space Station, and it had a number of different technologies on board. So I've just put a couple of pictures in of some of the technology to show you. So it had the net capture that was capturing a CubeSat. It had the VBN, so visual based navigation camera system for alignment that you would typically need in a docking scenario. And it had the Harpoon target assembly. I personally recall trying to go to the NASA Space Center and convince them it was a good idea to let me put a Harpoon on the space station. Interesting conversation, but luckily our friends at NASA were on board. That was launched successfully from the ISS and trialed successfully. So again, that also has a deorbit sail, and that also continues to be monitored as it comes down. So as you can see, in the past, the UK has led the way in looking at some of these technologies and trying to find a way forward. And I'm continually impressed by the way that UK and academia work together in this issue. On recent calls on debris removal, I was extremely surprised pleasantly by the number of companies reaching out to SSTL, wanting to work in this area, wanting to have technology that they thought would be useful, that they'd like to trial. So going forward, and again, I'd already used the analogy that Maurizio had on the roads. Safe use of space is not just about removing the debris there, it's about understanding and managing the whole environment, as the last presentation touched on. So we need to think about, do we understand the environmental conditions in which we're operating? Is there ice on the road? You know, we need to understand space weather, and we need to look at technology there. Do we understand what's around us in the environment in which we're operating in terms of debris, planets, other satellites? That's space situational awareness, space domain awareness, as it's sometimes referred to. Do we need the service effectively to keep the car going? You know, we're on the road. Can we keep these missions useful? Can we do something with them? That's where you start getting into the in-orbit service missions and life extensions in this area, so we can continue to make use of what's there in a safe way. Is it time for a tow and scrap? That's your debris removal missions. So when things have come to end of life, can we safely get them off the road, get them out the way, and dispose of them safely? And then at the bottom, and again, touching on, you know, are we all driving to the same rules? You know, are we using the same highway codes? Are we working in the same way? And that's the regulation and policy that's so important in this area. I'm already a little bit worried about driving to the same rules, because I've seen the argument in the chats about the traffic lights and the roundabouts. I'm going to plant myself firmly on the roundabout team there, just to be clear. So the enabling technology in each of these areas, there's going to be different technologies that we need to look at developing, but there is certainly a lot of crossover here. So for example, we've got the challenges. So in space weather, we need the near real-time data. We need the environmental monitoring, and it needs to be a service-oriented sort of craft. So some of the technologies we need to look at here, it's the inter-satellite links, it's the ground station network coverage. You know, how do we get the data down quickly and as fast as we can so that we can act on it responsibly? We need space weather instrumentation and scientific instrumentation. So this is a great way that industry can work with academia in this area, because there's a lot of good work going on here. And then for the service oriented, we need to look at the availability and the reliabilities of the platforms. Sometimes you have platforms that are sort of what we call fail safe. In a lot of these scenarios, we can't have that. We need the platform to be available when we're using it, because, you know, the criticality of some of these things. SSA and SDA, it's, you know, we've got to track small, rapid objects in very dark environment. We've also got the real-time data problems that we need to get the data down fast, particularly if we're trying to track an object or we're trying to avoid any potential collisions. We have agility and stabilization due to the environment conditions. It's not the same as EO with the lighting. We need to look at things a lot longer to get the details, so we need to be able to hold those platforms and payloads stable. Potentially onboard processing. There's a lot of data to come down, and trying to get it all down, we need to make sure we're getting down what's useful to give us the best chance of doing that as quickly as possible. So some of the areas we need to look at here, it's the high performance sensors. So we're working with some of the companies in the UK looking at the type of sensor technology that's available. It's the inter-satellite links, it's the ground networks we work with. We need to look around the AOCS solutions of the platforms, the onboard data handling of the platforms, what that can do, and the availability and reliability again of those things. We've recently won a study with ESA, part of the InCube program, where we're looking at onboard processing on our data handling units. And again, this would feed into some of this SSA and SDA work. In the in-orbit and service, you know, you've got the capture and assembly technology, you need inspection technology, you need the guidance, navigation and control systems. So again, the type of technology there that's interesting, it's the propulsion, the robotic arms, the docking systems. You've got close proximity sensors, which are obviously separate to the large EO sensors that we use for imaging. High frequency guidance and navigation ops, etc. So there's a different set of challenges there. In ADR as well, you've got to look at the safety of the platform. So we don't want to be creating debris on one of these missions. So how do we make sure we can safely dock, capture, grapple and remove? So those, we need to think about those things. The capture technologies, so again, we've seen from some of the previous mission, we have the nets, we have the harpoons, we have some of the robotic arms. There's some great work going on there. Again, docking systems, There are the sort of things that people are looking at. Again, you've got the real-time data. If you're coming up for an approach and a rendezvous, you probably need to get imaging and you need to get it down quickly to be able to see what you're doing. So again, it's that real-time data problem is there as well. You've also got the security features around the software, the cyber secure, that, you know, we don't want anyone to be able to come up and grab any sort of satellite. So you need to think about the security ramifications and what sort of security we put on those crafts. And then we've got sort of planetary defense. You know, we need high delta V, that's another one, as well as the environment around us of satellites. It's a planetary defense. You know, target initial acquisition, asteroid deflection, all those sort of things. There's technologies there as well. So as you can see, there's a broad range of technologies and they need to be aimed at different things because it's a far-reaching problem. And I think to sustainably use space in the future, we have to consider all of those areas. So in conclusion, the UK has an impressive history in demonstrating space safety technology. It has an extensive capability across industry and academia and a real willingness to work together and find solutions, which I think is fantastic. We're already working together in a number of areas, consortia on some studies to try and push this technology forward in different areas. But as I say, there's a huge number of facets to the secure use of space and a lot of technology needs. So there's a huge market out there for all different ideas and different people to come together with solutions here. As I say, a number of these are being advanced and we are encouraged by the National Space Strategy that really puts an importance on doing these type of things. And I think the important note at the bottom is the UK has set the tone in policy and in regulation, and we need to build on it with example. And I think one of the things to think about is, you know, it's the enforcement of the policy and the regulation. So do we want to think about that? So we've set these rules. How do we want to enforce it? And do we have any needs there? So as I say, that's all I wanted to talk about today, just to basically stress the message that we've done some great things in the past. We've got some great capability in the UK, but there is a wide range of things that we need to do going forward, and there's room for everyone.
Thanks, Victoria. That's excellent. And it's really great to see this work going on. I'm sure it stimulated some questions. I've got a couple of my own, but I'm going to hold them back and do the panel session. So thank you so much, Victoria. And now our last presenter for the morning session is Professor Mark Ventresca from University of Oxford. And Mark, I believe, is going to talk about governance and some of the things that Victoria was just talking about on the international stage. How do we govern this? It would be very fascinating to hear your views. So over to you, sir.
Well, thank you very much. And thank you, everyone. Great to be here. I'm Mark Ventresca. I'm a faculty member at the Said Business School at the University of Oxford and a governing body fellow of Wolfson College. And I'm going to bring my slides up in just a minute. Oh, great. Okay, you did. That's super. I'd like to talk a little bit about governance, and I want to really support the issues and insights of the first three colleagues who've spoken, Maurizio, Massimilio, and Victoria. They've actually done a lot of work for me. So my comments really are going to build on the very rich issues they've outlined. What I'd like to invite you to do with me, though, is to reflect not on the technology drivers or the very remarkable developments at basic research and also the applied technologies that we've been hearing about. I'd also like you to think with me about the potential for governance and what that means. The title of my talk, Space Sustainability, a Commons Governance Challenge writ large, some of you will know is a reference to the work of Elinor Ostrom, who got the Nobel Prize in 2009, for her work engaging long-time questions of how do we govern common pool resources like timber, fresh water, fisheries. Ostrom's work is remarkable, and I think we'll learn more and more about it in the coming years, because she took on what were basically two solutions available in the world for the last 80 years. One was creating property rights, and then hoping that the market will deal with these questions of governance, or invoking the power of a leviathan, of a state, an authority that will adjudicate. And the challenge for Ostrom, I think the challenge for space is really, we don't know how that's going to work. We know it hasn't worked very well, either the state or property rights in earthbound solutions to governance like fisheries, timber, and the rest. The issue there is, as you know, is not what happens today, but what happens over time. And I'm going to talk more about that in a minute, the tragedy of the commons. So what I'd like to, I have a few slides. I'd just like to work through a couple of ideas that are really resonant and reinforcing with what all three previous speakers have said. And then I want to talk with you a little bit about the Ostrom's governance of the commons, and then spend a few minutes sort of speculating for the framework that she left us going forward. So just very quickly, my group at Oxford, the Oxford Space Initiative, David Lehman is on the call today, Liu Shi is on the call, Michele Scatolini, others. We're basically a group of social scientists who embrace the technology questions, but embrace them not as determining or driving, but actually as new kinds of problems and solutions that we have to manage with new kinds of institutions. So again, all three of the prior speakers have at some point in their talk talked about, Massimo in his early, Maurizio in his early comments said, the very fact of space development, commercial development is already showing us the limits of available governance and the thinness of regulation. Victoria, again, just briefly mentioned to us same issues about the need for regulation and the need for imagining ways to collaborate and cooperate. And so we start from those social science questions, attentive to technologies. We've heard today from all of our colleagues a lot about space debris removal. I could add to that, and many of you on the call know this, I could add to that questions around asteroid mining, around claiming rights on Mars. I would put this in the context of the current heating up of geopolitics, the tension and competition between the US and China, with strong efforts by by European countries, Germany, the UK, and others to have a voice in that, and a lot of attention to the role of countries across the continent of Africa, in Asia, and so forth. So we could look at lots of issues which are all the same. They're technological possibilities with commercial potential, and they are right now under resolved. And I think Victoria really talked through that in a very detailed way. So Munimar, if we can go to the next slide, please. You can just go ahead. So I just had a slide here saying, I think we all know that what's driving a lot of this has been the remarkable development of SpaceX launch capabilities and the dramatic reductions in cost of access to space. This is one figure of many that we could look at that basically reminds us how fundamentally changed is access to space. And again, Victoria and Massimilio and Maurizio all talked about the growth in the number of satellites being launched. Enormous opportunities. I work with some of the ventures coming out of Oxford today, Little Space Labs, Spark Geo, which are basically ventures that are looking at how to use satellite data. They're the companies that are pioneering what some people call satellite edge computing. So, I put this here just around this. This is what's going on here is the dramatic reduction in the price of accessing space. And as all the prior speakers have said, I'll say the same thing. That means a lot more stuff is going into low Earth orbit, and that's the basis of many both opportunities and also problems. We can go on to the next slide if you would. And so the question that we're working to is space, in that sense, a candidate for tragedy of the commons? And if so, then what? So what's the tragedy of the commons? 2 minutes here on this debate. First, I'll mention 5 developments. We have a recent blog post. Maybe, David, you can put that blog post in the chat if people are interested. It's an Oxford Answers blog post. I think the colleagues have already spoken to this. Dramatic changes in the nature of commercial activity in space, the erosion of NASA-dominant ecosystems, and the rise of an intermediate space like SpaceX, an intermediate period of high subsidy. The growth now of lots of commercial ventures and venture money going on. A second broad issue is the renewal of interest in national space agencies. As many of us know, there are probably 25 countries in the last 10 years that have founded new national space agencies. Those agencies are focused very much more on what some people call space for Earth. They're focused on using satellite data to address the sustainable development goals and so forth. Another broad development is the increasing complexity of micro relations within the space sector. So lots of new kinds of partnerships, collaborations, and the rest. Again, I'm going to stop there. We've heard this from all 3 of the prior colleagues. The dynamics of the global space sector are changing. The tragedy of the commons, though, is an interesting idea. It comes from early work in politics and economics on an old idea, overgrazing of lands, where you and I today let our sheep graze too heavily, And then next year, there's no grass for anybody's sheep to graze on, resulting in tragedy. So the core issue there is overuse and eventual degradation of common pool resources, such as grazing lands, fisheries, timber, and water. And the argument is individual actors, whether individual people or firms or countries, have no real near-term incentives to limit their overexploiting of those common pool resources. I get the benefits today, and I don't really have to bear the costs of that collective degradation tomorrow. This problem points to the governance mechanisms. As I said, one solution has historically been property rights. Define property rights carefully and well, and let the market take over. So in a sense, you eliminate common pool resources, you commercialize them, and you make those public resources into private resources to avert tragedy of the commons. The second broadly has been Leviathan, build a political authority or a government to do that. And the third, and this is the Ostrom work, has been to talk about what she would call polycentric governance. That is, building institutions which are plural, overlapping, clumsy, inelegant in the sense of they are not elegant solutions like a market solution, but in fact, they depend on a lot of interaction, norm setting. So she would say formally independent centers of authority that interact in the allocation, regulation, and sanctioning decisions, commons governance. And I think there's an opportunity here. I think, as I said, much of the work in this, in political science, in the social sciences, in strategy, has looked at earth-based common pool resources. I think there's interesting opportunities to reflect on space itself as a common pool resource in all the ways that we've heard today, the cluttering up of space with space debris, the kind of claims making, which country or which firm is going to lay claims to particular jurisdictions or planets or zones in space. I think if you saw in Science a few days ago, the journal Science had long conversation on space becoming a site for new kinds of environmental contestation for the reasons I think that Maurizio and others have mentioned. So the issue is, I think if we think of space conceptually as a commons problem, we need to work through the nature of how do we govern that. If we can go on to the next slide. These are just a couple of quick, I put in here sort of some of the efforts. Victoria mentioned the UK's prominence in this. You know, right now there are many debris mitigation efforts going on. There are many solutions. We've heard several of them in the prior presentations. We know the UK last year committed a substantial amount of money to really trying to understand questions of low cost, low Earth orbit activity. ESA commissions world's first space debris removal, clear space we mentioned earlier. I could mention Astroscale, a Japanese-based venture that is leading and introducing new kinds of technologies and so forth. So the point is, there's a lot going on here. It's not settled. We heard from OneWeb today in Maurizio's presentation. These are unsettled spaces, and that's the nature of the commons governance. If we go on to the next slide, please. So these are just two slides I'm going to move, but this is just summarizing from a colleague, Paul David, that the space junk removal is not going smoothly. Despite our optimism in the plurality of experimental technologies, there's not a solution yet. Again, you can just go to the next slide, and then just one more, the last slide I have. So the Ostrom challenge, Ostrom's work has been very successful at helping us understand over time stewardship of resources on Earth in small communities where there's opportunity for face-to-face interaction, norm setting, clear kinds of sanctions and graduated sanctions. You can, if you look in that first column of this table, you can see salience of actors' awareness, distribution of interest and power, cultural and institutional homogeneity, feasibility of learning, and so forth. These conceptual tools map onto many of the issues that Victoria just shared with us. And the point of this, where I'm going to end the presentation, is we know that Ostrom's work is effective in these local natural resource spaces. The question is, how do we extend that to a global commons? How do we begin to take up these questions of space and think about plural institutions, creating the kind of immediacy and intimacy of face-to-face in what is truly a cosmological space? How do we begin to build the institutions? And this is where many of the current initiatives see either a venture, an agency like UNESCO, or collaboration between private firms as the solution. I want to pose the Ostrom challenge. How do we build layered, sometimes contradictory, inelegant institutions that help us manage the competing and plural interests and identities. So let me stop there and we'll have time for some questions.
Thank you, Professor. That's really helpful. Can we bring all the panelists back to the forum, please? So perhaps we can see everybody. That's brilliant. Thanks, hi, Victoria, Mark, Maurizio, and finally,
Massimiliano, I think is there.
Massimiliano, fantastic. So it's not Massimiliano, it's Professor Andrew Lawson. So I'm sorry. Okay, well, just we've got a few questions that have come up, and I'm going to paraphrase them, but reference a few people. So Mark Mayer has mentioned about the role of some of these international organizations and perhaps even member states of the organizations and their role. So with regard to organizations like the ITU, like you and NUSA, how do we see the roles developing between industry and the institutions? So maybe I could just ask initially your thoughts on that, Mark, the interaction between the different organizations, and where do you think the responsibilities should lie?
So did you ask me? Would you like me to start?
Yes, if you wouldn't mind.
Thank you, Paul. Yeah, it's a really important question. I think that right now, as many of us know, space is thinly regulated. It's been dominated by government initiatives. There's a few treaties and understandings. Things today like the Artemis Accords are an effort to organize that. I think all four of us on the panel have talked about rules of the road or rules of the game, and I think those metaphors are very powerful. Right now, we're not starting fresh. We're starting in a space literally organized by large, powerful national governments, increasingly around issues of cybersecurity and information by large global technology companies. There are questions around equity, both at the level of nations around the world and other kinds of actors. I think that this is going to be a tough conversation. Our colleagues at IESE in Biz School in Barcelona, Fabrizio Ferraro and his colleagues have given us a tool, a template for how you work in these large, intractable, stalled arenas of governance. And they say you convene people and you have a series of debates and arguments. You recognize that initially no one's going to have anything to say. We're not going to see common interests. We're going to be grumpy in many ways. But you convene people again and again over a couple of years. And then you begin to try experiments that you build up capabilities, you build up the possibility to do what Stuart Kaufman at the Santa Fe Institute talks about as the adjacent possible. So my view on this is there's no right way to start. We need to bring many parties together a couple of times a year over a couple of years to begin to both develop common ground, a recognition that we have to pay attention, we have to work in new ways together, to do experiments, to try things out. Again, Victoria mentioned many of the pragmatic activities going on. And I think that's where we go. And it's going to be a 3 or 5 or 10 year process, all during which space debris is going to be accumulating at an enormous level. I think we've all said, thousands of satellites projected to be launched in the next 2 years.
Thanks. I just to another question actually, and maybe Victoria, you can comment on this. It's from Pratik Kumardonga from Cardiff, who's basically asking about the missions that we're putting in place to potentially explore how do we combat space debris, whether they are creating challenges themselves, and when should we start using them as opposed to start experimenting?
So yeah, I mean, the missions we've put in themselves, some of the early ones with just the sails, they're not being taken down, like you say, in a controlled active debris removal, but we have to advance the technology somewhere. So you have to take some small risks to start with to understand more the technology, what it can do and how you can then grow it and use it in a sustainable way in the future. So yes, there is a small amount of risk up front, and those sort of missions, but you still manage them in the way you would an active satellite. So for example, when Demosat is coming down, we still monitor it as we do any of our other satellites. It's still subject to the conjunction type warnings that we get from the relevant authorities. We work and coordinate. People know it's effectively a dead satellite that can't move now, so they have to move out of the way, but it's not just left there causing a problem on its own. So yes, as we grow, we can't go straight to the perfect solution straight away, but we have to try out and develop these technologies. And I think the best thing we can do is these type of demonstration missions, the TDSs, the recent ADR call, the remove debris, is let's get this technology trialed, tested, let's understand it, and then companies will start to use that and start to include them on their missions. So I think it's going to be an iterative process, just following on from what Mark said with the regulation. It's going to be ongoing.
Thanks, Victoria. And I know that SSTL was really one of the vanguard of small satellites and the innovative approach for creating low cost. And maybe that's pertinent for the next question as well. And maybe I'm going to ask Maurizio on this. So we talked a little bit about technologies to avoid fragmentation, to assist in removal of the assets from space. But one of the other things that's been mentioned and helps to reduce the cost of access to space is reusability and replaceability, if you like, effectively using assets that are up there. So there's some questions about, and a couple of questions here, with regard to the aspects of technologies that would help us to support potentially reusing missions or recycling missions. Maurizio, any thoughts yourselves on perhaps what future spacecraft might look like, whether you've got thoughts on the technologies that might help you to extend the lifetime and capabilities of that?
There's a lot to being discussed about extending the lifetime of missions through the initial demonstration.
Switch these guys off.
Can you hear me?
Yes, we can. Please, can you turn your mic if you're not talking, but mic down. Thanks. Keep going.
Okay. Okay, sorry. We're looking at life extensions, considering refueling of missions. So there's a lot being discussed about the modularity. Again, this is one of the things I had in the back of my mind when I was talking about uncharted territory. Right? There's a lot being discussed about modularity, having standardized interface that would allow docking from different service providers. Going back to the analogy of the road, we're really talking about tow tracks here, if you allow me to simplify the concept. And you have on our roads multiple companies, multiple service providers, and this can be done because cars are sort of standardized in shape and form, and you have multiple companies that with multiple devices can come and serve you. So trying to move away from the concept that each satellite is a prototype, and actually developing common interface is one of the challenges in order to enable to foster a kind of a virtuous cycle that would enable through modularity and compatibility and standardized interfaces new kind of missions to be enabled and new services to be provided.
Okay, thank you. That's excellent. So one of the related aspects, and we've touched on this already, but Kumar Singaraja is asking about he's asking the question specifically about LEO operators and governments, but I think there's also, Victoria, you touched on this, the aspect of minimizing damaging or hazardous effects of hundreds of thousands of small debris in the 1 to 10 centimeter size. And really, is it realistic to be considering about space situation awareness and space asset space traffic management in the context of this cloud of debris and dust? Anyone want to pick up on that to start with? Maybe Victoria and Maurizio, you could comment.
Yeah, I think space situational awareness is an interesting one. It's been a bit of a buzzword, for want of a better phrase, recently, but it's a wide-reaching thing. Part of that is the LEO observations, But when we're talking about space situational awareness, there's different things you can do. So it's, do we want to catalogue LEO? Do we want to focus our attention in understanding those smaller parts? Do we want to look at the satellites in the area? Do we want to offer services or look at technologies where we're looking from LEO out to GEO to provide some sort of observation on the GEO operators? So it's a wide ranging thing, and absolutely understanding the environment and the small debris is very much a pertinent part of that. And we need to look at how we can best catalogue that, because that is going to be a very challenging problem to do. And that's why we need to look at the type of sensor technologies that can look at those things and identify them. But it's certainly an important aspect of it.
Okay, thanks. And I think there's some related questions here. Chris McKenzie has asked a question about the materials in the upper atmosphere. So not only is the debris causing a hazard potentially to the satellites, but also from a planetary perspective. And I think maybe Professor Massimiliano could actually respond to that particular question about, because you're touching on this, about the amount of matter that would be deorbited.
No, indeed. So I think that it is not a problem at the moment, but it's definitely something that is going to be a problem. And it's just a matter of total volume of matter that is re-entered and is dispersed in the atmosphere. And if I can also say something about the SSA, I mean, SSA is only one part of the problem. That's why we're now talking more about managing the space environment as a whole, which includes more active actions rather than just monitoring and surveying the events. So.
Okay, that's understood. We've got quite a few more questions, only a couple more minutes. I'm going to ask if Helen Shell, who made a question about the business case for recycling, etc., if you could ask that this afternoon, Helen, because it's better for the panel there. There's a couple of other points here I think maybe it's worth just touching on this community. One, which is a bit of a wild card. The first one is about, we talked about SSA, the role of the defense sector as well, and perhaps infrastructure that's being deployed, such as new space track radars that are being put in place. How should space be supported by both the civil and defense communities? And maybe this is Mark, you could just comment on this, the actual interaction between those investments that are being taken place for defense purposes and how they would interact, and your thoughts on building that into a governance framework.
Yeah, thank you very much. And thank you, Helen, for the comment. Your comments all throughout have been great. I think that there's, so we could think of this in this way. There are exciting opportunities trying to explore through literally finding and building energy resources in space that would change the balance of the efforts to move away from an Earth-centered launch capacity. There are efforts and companies and commercial initiatives trying to figure out just the question you're saying, could we do recycling in space? This is part of that elaborated problem around space debris. And it's in several of the questions. So once we have new satellites, what happens to the old satellites? We use sails that Victoria was talking about. We use various kinds of capture and harpoon technologies. What do we do with that stuff? Do we incinerate it? Do we create more pollution in space? So I think that, there are many efforts. There's no solution yet in sight, but I think the richness of funding and the richness of the scientific imagination is exploring all of these issues. It comes back to this really core question. Humankind has put a bunch of stuff into space, and we don't really have a way of either controlling that so that it doesn't cause collisions, nor of disposing it in a way that is not going to damage space. And there was, as I said, there was a recent piece in Science a few days ago on just these issues of space as the new focus of environmental contestation. So I think I trust that we have many colleagues and many firms working on these issues. There's no solution in sight yet, but I believe in Kaufman's adjacent possible. Those efforts to try out solutions, however incomplete, help us build capacity to eventually get to a better solution.
Thanks. I'm just going to finish with a last question. Actually, Jeff McBride from SFC mentioned this, and I think it couples quite nicely. It's about the potential for other types of operations, such as high altitude pseudo satellites and the like, and us investing as an industry, perhaps in transferring some of our capability in with regard to the totality of capability. But I'd like to bring it back to, if you want to reflect on that, to the aspect of why are we doing this? And it's really about developing capabilities that address some of our challenges on a planetary scale. And just one last minute from, well, no, not even a minute, just a 10-second shot from everyone on the value of the work that we're doing as a space sector with regard to addressing those sustainable development goals, and the carbon footprint, the carbon offset that we could get from recognizing that. So I'm just going to quickly go around the table. I'm going to start with, I'm going to finish with Professor Massimiliano Vesely. So Victoria, your thoughts on sustainability and our impact?
I just think we have an obligation to look at space as a huge environment. We can get so much benefit from it, so much technology on Earth derived from space. We have to keep making sure we use it safely in the future. So we have an obligation to look at that sustainability.
Thanks, Victoria. Maurizio?
Yes, Paul. So fundamental aspect, the WEF, the World Economic Forum, is looking at space sustainability ratings. We are, actively, engaging with these kind of initiatives. So it's our obligation. Fully agree.
Okay, thank you. Mark?
For today, at least, I'm going to not be an optimist. Despite the wisdom of my colleagues, I see these as unsolvable issues, and I think they will help to define the fate of both this planet and the human race.
Oh, well, okay. Well, perhaps Massimiliano, you can give us a slightly more uplifting response, or maybe not. Give us your perspective.
Well, history has taught us that when we are not very good at dealing with these problems, because everyone is generally looking at their own turf and not really worrying about the global effect. But I'm optimistic. I mean, from a technological point of view, there is a lot that we can do, and we have done a lot on Earth, so why not?
Thank you. So a very interesting range of views from the panel, and I'd like to thank you all so much for your presentations and conversation today. And I do believe, that I would do, of course, that we can actually put the technology to good use and we can make space sustainable. I agree with the entire panel that it is our duty to make sure that is the case. So we're going to take a 5-minute break now. We're just a couple of minutes over. So if I could ask if everyone could grab a coffee or whatever you would like to drink as your beverage. And Professor Conor McKinn is going to host the next session at 11:15. We'll make it 11:17. Sorry, Professor, just slightly 2 minutes off your schedule. So welcome to you all back in 5 minutes time. Thank you very much.
Thank you.
Hey, colleagues, welcome back. I'm Colin McInnes. I'm from the Space and Exploration Technology Group at the University of Glasgow. The second session is a slightly different format. We have five 5-minute presentations, which are going to broaden out the discussion, covering sensors, collaboration, light pollution, alternative propellants, and servicing. So we have 5 speakers. What we suggest is that we leave the Q&A discussion to the end, and any questions, if you can post them in the Q&A channel, please. Also for the speakers, again, we've got 5 minutes, so we're a bit of a schedule. I do have a timer, so apologies in advance if I give you a little bit of a nudge if you're running over 5 minutes. So if we could move on straight away to the first speaker, who is Ralph Dinsley, Executive Director at Northern Space and Security. And I'll hand over to Ralph. Thank you.
Good morning, everybody. I'm unsure if I'm coming through at the moment. Am I coming through?
Yes, you are, Ralph.
Yeah.
Okay, yeah, Colin just broke a bit, so I didn't know if that was my end or not. Thank you for the introduction. I know I have very little time. Just to confirm, Manuel, you'll be moving through the slides for me to help assist,
Yes, I
is that
will.
correct?
Yep, that's correct.
Brilliant. Next slide, please. I notice coming from you live from Tyneside in Newcastle, and because I'm here for the viewing of our very own promotional video, and what you're about to see in a couple of seconds time will be the work in progress that we had prepared for today, and then the Norse promotional video will come out. But I noticed a lot of discussions were out in space situational awareness, what is also being known as space domain awareness now, and it was highlighted quite heavily in the UK space, the National Space Strategy. And
Hi, Ralph. I don't know if you can hear us. You're breaking up a little bit. You may want to switch off your camera for now.
In space, what's going to and coming out of space. And okay.
Hi, Manoir. I'm getting nothing from Ralph either. I know that Ralph has a video, so perhaps we should maybe just move on to that video slide, and then hopefully Dins will come back.
Sure, will do. Thank you.
Really, I seem to drop out briefly.
It's big. Mind-boggling to wrap your head around. Just whopping swathes of emptiness peppered by clumps of dust, stars, black holes, radiation, and more emptiness. But there is this tiny bit from just 100 kilometers up that's vital to how we live. That's where satellites operate. The world is run by them as they orbit above the Earth. We wake, check apps, the temperature, wind direction, rainfall. We use them to beat traffic, find a restaurant, shop from the couch, do our banking. They beam down what we watch, listen to, hear about, and they bring us together wherever we might be in the world. Space. We're more reliant on it than ever. But the more we shove up there, the more clogged it gets. Collisions happen, big bangs, satellites clanging into each other at 17,000 miles per hour, causing fragmentation, space junk, space waste, space pollution, space trash, debris, defunct artificial objects floating around in Earth's orbit. Imagine a life with no telly, No phones, no defense, no weather warnings. The sky's not falling in just yet. But we can only understand what's going on up there if we can measure it. We're NORSE, specialists in space situational awareness, SSA. If it's up there, we can map it, understand how it's behaving. We're curious humans that deal in data, looking for truth, observing everything above our heads to help people operate safely in orbit. No other UK company operates in the space we do, watching, coding, understanding, reacting super fast, developing our own platforms, projects and sensor systems, mapping areas of the sky not mapped before, tackling new dimensions, keeping space safe, keeping you safe. What we observe, we bring back down to Earth, because space is for everybody, so we need to take care of it, make it sustainable for future generations, and take responsibility now. Space. It's big.
Charlie Brown, Houston, they got staging. They had a wild gyration, though, but they got it under control. Over.
But the question we should ask ourselves is space forever? Next slide, please. We need to understand more about what's happening on space. And I noticed from the earlier presentations, there was questions or statements about the military heritage. But the problem is we are where we are now because too much information hides behind that firewall. Northern Space and Security are dedicated to growing the experience beyond the military realm to democratize the data of space and understanding of space. As that video would have shown you, we talk more about space is for everybody, and it's essential that we can talk in the language of the average person on the street, so they understand that sustainment is not just a terrestrial requirement. Next slide, please. So what we do, we are the only company dedicated to space situational awareness. Amongst the key partners in the company, we have over 60 years of experience in space situational awareness, space surveillance tracking, and space domain awareness. And we have a young team of engineers and analysts who, over the past 3 years, have been developing that experience as well. We're handing down that information to ensure future understanding. We were founded in 2017 and we now have a staff of 18, and we're just about to advertise for more people. And being one of the very few Northeast based companies, we're ensuring we can develop the local infrastructure and skills to be able to export that experience and utilize that experience properly. Next slide, please. But it's very important that we get the word out to the community, to the broad community. Next slide. To ensure that people understand the need to be able to support the long-term sustainability in space. We're developing our own SSA capabilities, optical camera systems, alongside their colleagues at Kilda Observatory. So whilst they're looking at the stars, we're looking at the satellites, and with growing experience across a young team of analysts to ensure that we can have a sustainable footprint for long-term space requirements. Next slide, please. And at the end of the day, we're dedicated to ensure the benefits of space for future generations through sustainable growth on Earth amongst the engineers. We actually also have an apprenticeship. We have the first UK orbital analyst apprenticeship available. I believe I've probably gone close to my 5 minutes, and with my connectivity, I will stand back and answer any questions when the opportunity arises. Thank you.
Okay, thanks, Ralph. So yeah, again, any questions for the speakers in the second session, if people could post them in the Q&A channel, and we'll come to those just at the end of the session and the panel discussion. Okay, so we'll now move on to Dr. Jason Forshaw, who's Head of Future Business UK and Europe at Astroscale. So I'll hand over to Jason.
Thank you very much. Just share my screen. Can everybody see this okay?
Yep,
Yes,
all good, thank you.
Yeah, okay, perfect. Thank you very much and good morning. Today I'm going to be talking to you about Astroscale's activities and our work on active debris removal and in-orbit servicing and how we support a sustainable future in space. So Astroscale is a global international company. Our vision is the safe and sustainable development of space for future generations. And we have a range of different services such as end-of-life active debris removal and geo-life extension. And as you can see here, we've grown quite a lot. I think it was mentioned that we are a Japanese headquartered company, but I think sometimes it's not appreciated that we have a lot of other offices. The UK office has almost 70 staff now. In total, we have about 240 staff across the business in the UK, Japan and US offices. So just to give you a quick summary here on some of our space activities, we're involved in a wide array of programs, and I'll touch on a few of these later. But the first thing to mention is ELSA-D, which launched in March, and this is the world's first commercial demonstration of active debris removal technologies. We successfully completed a test capture phase earlier this year, and you can find out a bit more about that at IAC. With respect to our future debris removal servicing missions, we have ELSA-REM, which I'm going to be talking about shortly. Over in Japan, we have the ADRAS-J and ADRAS-J2 missions, and the first stage of this JAXA mission is to actually rendezvous and inspect an H2A upper stage. So the aim is to actually do this inspection with the aim to remove it in future at a later date. And you can see here, right out in GEO, we are developing life extension services over in the US. So this is quite a summary of all of our different types of activities. So with respect to space sustainability, I'd just like to say that we really have three kind of themes in our business which we try to work on. So we try and work on developing the technology, and you've seen that from some of the missions I just showed. We work on developing the business case, and we work on developing the regulation and policy side. And I think it's been shown throughout this conference so far that the number of satellites in space is massively increasing. As is mentioned, we're moving from more government services to commercial services. There are plans for tens of thousands of satellites to be launched in future. And I think it was shown in both Nors's video and a comment in the chat that there is a range of small lethal debris up there. And we have to be cognizant that no matter how reliable your satellite is in space, there is lethal non-trackable debris that will mean a set percentage of your satellites are going to fail. And we need solutions for this. We do need active debris removal missions to push forward and start cleaning up space. So I think one of the things that's quite clear here is that there's growing support, growing traction for the development of the sustainable use of space. You can see here there are a few quotes presented from the G7, from OneWeb, from other entities, showing that they understand that debris removal and future in-orbit servicing is becoming a bigger issue, and we can't wait, and we need to do something about it. And debris removal services are part of the solution for helping to make our environment more sustainable. And you can see here an extract from the National Space Strategy indicating that in the coming decades, emerging technologies and applications are going to develop entire new markets, such as in-orbit servicing and active debris removal. And I think it's now becoming understood that, regulatory wise, there has to be something done in those regards as well. So just to summarize really on some of the programs we're involved in, our programs do support the broader space sustainability agenda. We aim to grow the in-orbit servicing market in the UK to support the space sector growth ambition. I think many people will know that we co-founded the IOSM working group in the UK, which is part of UK Space. And through that, we aim to try and push forward the development of these critical technologies, but also the policy and and government angles as well to ensure things happen in this domain. So just going through a couple of our programs, ELSA-D, as I mentioned, this is one of the world's first missions to test debris removal technologies, launched in March. From a UK perspective, this mission was licensed with the UK Space Agency, and operations and ground segment is with the National Inorbit Servicing Control Center, which is embedded in the catapult. And of course, that was developed with Astroscale Prime with various contractors such as Catapult, RIA, GMV, and CGI. To also note as well, I mean, that it's been quite a wide supply chain for ELSA-D. We've had SSTL, of course, making the client satellite for that. But to give you an indication moving forward with ELSA-M, which is our next generation commercial service, we've been working with ESA and OneWeb on the Sunrise program for almost 3 years to try and commercialize the elements of ELSA-D and to develop this ELSA-M. And it's called ELSA-M because M stands for multi-client. I think there was a question before on how do we minimize the number of missions that we launch for these type of things. By having multi-client missions, such as you launch a single servicer and it can remove multiple clients, that's one solution to that. So what we are proposing is that in 2024, there could be an IOD with preliminary service offerings beyond that. And this would be the first time where ADR would have been demonstrated with a full-size constellation client. So we really look forward to that. Just a couple more points. In the past, UK Space Agency issued a call for an active debris removal mission, a phase 0, phase A study to look at developing a UK-led mission to remove a couple of assets in space. And this is fantastic that we've reached this level where governments such as JAXA and ESA and UK Space Agency have understood this is a pressing need and are looking towards solutions for this. A final note is on the docking plates. There were some discussions previously on standardization. Our COO is the chairman of COMFERS, which is a group that tries to look at standardization in orbit servicing. And we're proud to be a member of that. And part of that is considering, how do we commercialize in orbit services? And part of that is the interfaces. And one area is a docking plate. We're working on the next generation docking plate, which is a low mass, minimally intrusive solution, which clients can affix to their satellites before they launch. And the first generation of that was successfully tested on ELSA-D. So now we're looking at our next generation of that as well. So we'd like to give you more details of that at IEC and Space Tech Expo as well. So that's all I have from my side. Just like to say thank you very much, and I resonate with a lot of the comments we've had in this conference so far, and look forward to any questions. Thank you.
Thanks, Jason. We'll move on to our next speaker, who's Catherine Courtney, who's the chair of the Global Network on Sustainability in Space. So I'll hand over to Catherine.
Thanks, Colin, and thanks for all the great insights shared so far. I am going to do my best to share my screen, and I will try and be very disciplined. Now I just need to find, here we go. Let me see if I can get this to start. Right, if you can see my screen, then I might be able to try and squeeze in under 5 minutes. Let's see how we go. So I wanted to talk a bit about collaboration and the importance of collaboration. The speakers so far today have set out all of the interesting challenges that they are trying to work on from their different perspectives. What I'm here to talk about is the Global Network on Sustainability in Space. It's an STFC funded knowledge transfer network, which is really our aim is to forge collaboration between businesses and academics, scientists, researchers across the UK, but also internationally, in order to try and tackle some of these big problems. It's clear that it's complicated and a multidisciplinary effort is required. So the hard problems in space domain awareness, space traffic management, tackling debris and congestion I'm not going to read these. That's an eye chart for everybody, but I know you're going to get the slides. So with thanks to my colleague Stuart Eaves for, it's just a list of 13 hard problems that we still need to solve. But those are the sort of problems where actually there is relevant work going on already across UK research councils and funded researchers, developing knowledge, insights and techniques and skills that can be brought to bear on those problems, and not just from STFC, also across other research councils. And as we've heard today, it's quite important that I think there are skills required in data analytics, in technologies, but also from the social sciences side of things, as Mark has so clearly laid out for us. Policy, law, regulatory frameworks, economics, they all have an important role to play. So I'll just talk a bit about what Gnosis is trying to do to promote collaboration. We hold workshops. This is trying to facilitate discussions to bring scientists and industry together. Our next one is coming up in January around space-based space situational awareness. Please come to our website and sign up for that one. And coming out of those workshops, we have topics that the attendees feel really would be worthy of a deeper dive. And so we then follow on into sandpit events, looking really from those sandpits to try and emerge with some really interesting ideas for collaborative projects that people can work on together. Our next two sandpits are in December and March, and these are taking a much deeper look at some of the interesting questions that were raised in earlier workshops. We also are a lot about education, communication, and raising awareness, and attempting to reach out across the academic community, industry, and government, and try and raise awareness for government officials and for politicians about these issues. So I'd like to invite anybody with interesting things to say on the subject to submit blog posts into our website. And here's our one recent one. As you can see, we talk about a wide range of issues. We are also quite strongly aligned to the National Space Strategy's objective, strategic aim around raising skills. We have funding for part funding PhD. So we have one PhD already underway and have funding for a second. We also run, educational events, which is all about trying to get people from across the country to understand the topic and turn their brains to the problem. We have funding for small studies and proof of concepts. This is really just to try and get proposals to a stage where actually they can be put forward for larger chunks of funding, a kind of seed capital, if you'd call it that. We have published a series of technical challenges. That's not the only things that we'd be willing to fund, but it's an invitation for people to come and have a look at those and see where they might be able to bring their knowledge to bear. We held our first annual conference in September. It was a virtual conference with a wide range of speakers across industry, academia, and also from government. And we were quite pleased with the turnout for that. We had nearly 400 registrations from right across the world. If you missed our conference in September, then please, by all means, come to our website, you can go to our YouTube channel and catch up on the talks and discussions that you missed. Follow us on Twitter, look at our LinkedIn profile for news and views, and come and register to be part of the network. And that's it from me, Colin.
Great. Thanks very much, Catherine. I will move on then to our next speaker, who is Professor Andrew Lawrence from Royal Observatory, Edinburgh. Over to you, Andrew.
Right. Can you see me yet, actually?
Yes, we can see.
Okay, excellent. I shall get going. I'm going to try and do this with no slides, just talking. So I am an astronomer, and we do, of course, have spacecraft, for example, the Hubble Space Telescope, looking out to the universe. but we also work on the ground looking through orbital space. And like many of my colleagues, I got shocked in late 2019 by the stripes that started appearing in our images. So since then, as I'm sure you know, many of our colleagues have started working very hard on technical issues. My main role has been in public awareness. I wrote a non-technical book called Losing the Sky. You can get it on Amazon. It's very cheap, and your mum and your hairdresser can read it as well. I also ran a live public debate involved Catherine, amongst others, and have given many public talks. But enough of the adverts. I came here today expecting to make the case that we use space not just by working within it, but also by looking through it and by sitting underneath it. Now, in fact, I'm very pleased to see that it was pretty clear today that this is a well-accepted principle. And indeed also some companies such as OneWeb and SpaceX have entered into dialogue with we astronomers, and that has indeed been very fascinating, as Maurizio Vanotti explained. So you might ask, well, okay, so it sounds like things are going well. Why are we still worried? Well, the worry for me is about the speed of change. Now, this is where I might start to disagree with Victoria Irwin from earlier on. So I think we all know, and it's been very clear from the discussions, that we need some kind of improved regulatory framework, as well as improved technologies and improved industry standards, and that this will be for the benefit of all the various stakeholders and communities. But my worry is that this is going to take years. By the time we have our roundabouts and traffic lights, whether they are roundabouts or traffic lights, as it were, LEO would already be dangerously crowded. And what's more, one or two companies will have monopolized LEO, and that can't be good for business, as well as not good for the atmosphere, for science of astronomy, and so on. So the speed of change is extremely worrying. So I find myself wondering, how can we get responsible behavior now while the world gets its act together? So I don't quite know the answer to that question, but it is one of the reasons I did something a little bit more controversial than some of my colleagues, which is I got involved in the law. So I wrote a so-called amicus brief for the case which is currently before the US Court of Appeal, which, as I'm sure you know, was led by Viasat and was appealing the decision by the FCC granting the latest batch of SpaceX Starlink licenses on the grounds that it should have been subject to NEPA, i.e. to a formal environmental assessment. So the FCC have always insisted that they're not subject to NEPA. So Viasat and the Dish Corporation, the Balance Group and myself were all contesting that stance. By the way, I say, I'm talking about myself. In fact, in the background, I was helped by a lot of other astronomers. It was a bit of a community effort, but only my name is visible. It was only me that stuck my head above the parapet, as it were. So I do think that could be a pivotal legal case, which could set a precedent. The time for nice chat is over, and we have to get concrete and serious about these matters. Now, that doesn't mean it has to be a big government stick. I don't think it can be industry-led in various ways, but one way or another, we've got to get serious. There has to be something concrete, and it has to be soon, because things are happening very fast. The other thing I'm encouraged about in general, but certainly today, is that I think the mood and the intention is very good in the UK in particular. So within the UK, both in academia and in industry, both amongst astronomers and debris experts and so on, I think we have a great opportunity to lead the world in this area and take a kind of positive stance. But we got to get concrete. That's my message for today. Okay, so I'm going to stop there. So thank you very much.
Okay, thanks, Andrew. And we're now into the last speaker of the session, who is Derek Harris, Business Operations Manager at Sky Aurora. So I'll hand over to you, Derek.
Hi there, I hope you can all hear me okay. I do apologise, it's a little bit last minute. I'm over at the over at the World Expo, so I'll try and make this as quick as possible from the slides point of view. But as he says, I work for Skyrora, the rocket company, but I'm also the CEO of Ecosyn, which is what I'm here to speak about today. So those of you that don't know about Ecosyn, as I would say, is no time to waste. So it's a good time to go through for this. So at the moment, people see plastic as a problem. Only 12% of it is recycled worldwide. A huge amount of that, over 65% of the rest of it, either goes to landfill or is incinerated. Well, we've looked at that rather than a problem as a market opportunity as well, in a way that we can try and help space be a little bit more sustainable, a little bit more greener. So what do I mean by that? Well, there's a lot of profit that could be made if you could figure out what to do with the plastics. You can see just some of the figures from the areas around the world at the moment. There's huge amount of feedstock that could actually be taken if we could just find a solution for it. So step forward our innovative solution, which was Ecosyn. So Ecosyn takes previously unrecyclable plastics, or plastics that have a low recycling rate, and then gives them a second life instead of going to be incinerated or to landfill. So it can be turned into various fuel types, ranging from rocket engine, RP1, kerosenes, aviation fuel, maritime, and normal petrol and diesel fuels. How can we do this? Well, we build upon the pyrolysis, which has already been sort of done throughout the world, but we add in extra, our proprietary information and technology, which is our catalyst and hydrotreatment for that. And this allows us to be able to sort of tweak it like making a cake. So the different recipes or the different additives that you add will be there for whether it comes out as diesel, gasoline, kerosene, or whatever is required from the process. It's a pretty small system at the moment. So we've got our 3 containers, which builds the whole lab and the processing, and it can deal with up to 3,000 kilograms of waste per day. So per 1,000 kilograms of waste, we return 650 kilograms of usable fuels, and the rest of the weight is made up of gases and coke, ash, things like this that we're looking for secondary uses for as well. So the leadership team with that, as I say, myself, I came directly from Skyrora as a pet project for myself, as we have a big push for sustainability and to try and make launch greener. We have Andrew Menkoff, who's our head of R&D, who's worked in the space sector and various tech sectors for the last 20 years. Max is the man behind the technology. And then Alex is our head of business development, who is helping us source plastics for our test plants at the moment. So it's easy for me to sit up here and talk about our team and what they've done, but I think what's better for me to do is we've actually went out and we've showed the technology and allowed people to see the technology, and we've managed to gain a few awards for that. Most recently, one of my favorite ones is the Leif Erikson Award, which we didn't nominate for, or were not nominated for, but when they found out when Skyrora was over in Iceland, they heard about Ecosyn and they wanted to know more. And when they found out all the details, decided that we were deserving of the Leif Erikson, which was to do with greener and sustainable exploration of space. So it is no time to waste in regards to that. Apologies for the pun, I know it's a pretty bad one, but it's true. If we can figure a way to do that and then to give it a secondary life and use, it works. It's came out of space, but it can be worked in any sort of sector, as I say, between maritime and aviation. And we hope it's the first step to a much greener and sustainable source for fuels for everyone. So thank you for your attention, and I'm happy to answer any questions in the Q&A.
Great, thanks, Derek. So we've got just a little bit of time before we close at 12 o'clock for a Q&A and a panel discussion. So if there are specific questions that people have got for the speakers from session 2, please drop them into the Q&A chat function. Just while we look at that, if I can ask our speakers, Ralph, Jason, Catherine, Andrew and Derek, to put your cameras on and rejoin us just for this final kind of 5, 6, 7 minutes session. Given we're just at the end of the webinar, I thought it might be useful just to maybe take 30 seconds each. We'll go around the panelists, and based on either previous thoughts or what we've discussed at the webinar today, what would you see as the single most important step to deliver sustainable use of space? And if we can maybe start with Catherine.
Sure, thanks, Colin. People who know me will be bored with this already, but I actually genuinely feel that our single biggest key that will unlock progress in this area lies in the data. Because we do, Dens will tell you as well, we do have lots of data. However, data quality is variable. A lot of it is only shared and made transparently available to others on a need-to-know basis. And the modeling, is not particularly accurate. We have an awful lot of tools and techniques that have been used for looking at man-made objects in the night sky and evaluating their behaviors, etc., that really haven't changed that much since the 1960s. And so my view is that we need a great leap forward in terms of really being able to monitor, track, categorize, share that information, because let's face it, as Andy says, regulations will take a very long time. That's policy is a slow moving tool, critically important, but at the end of the day, you can't put rules that you can't monitor and enforce. And so really, I think a much clearer, better understanding of the data about objects, what's up there and how they're behaving, which is why Gnosis is so focused on bringing the astronomical community in to work on this problem, because they know how to work with big data.
Yes, Catherine. Yeah, I think that's an excellent point, that if we have regulations, then regulation can't be enforced unless you have the data to measure how regulations are being adhered to. So thank you for that. We'll pass on to Ralph again. Same question. Just what's your single most important step to deliver sustainable use of space?
We need to invest in sensors dedicated to space surveillance and tracking for sustainability's case. Right now, we utilize sensors that are optimized for missile warning, so therefore we're not getting the data. So from my view, the first step would be to actually invest in capabilities to get that data, and then we can start designing the way we do it. I believe it's no longer a military mission, a primary mission, and therefore civil systems should be invested in specifically to be able to monitor those objects and do more to ensure sustainable space. Because we invest in the sensors, we'll get the data will provide us with the informed regulation to ensure that we have long-term benefits from space.
Great, thanks, Ralph. So yeah, it's another vote for more and better data. Jason.
Hi, I'm going to take a slightly different angle here. As mentioned before, I think Astroscale realizes that in order to grow the whole market, we do need regulation, technology, and business case. I would say that probably one of the most important is the technology side. So that's why we've tried to engage in a range of programs such as LCD and LCRAM to try and develop this tech. I would say that, if you want to remove satellite debris, or you want to service a satellite in future, the most important thing is being able to dock with that satellite. So the rendezvous and proximity operations technologies, or called RPO, is essential. And so I think that's probably one of the key technologies and key things that will enable this entire servicing market.
Thanks, Jason. And Andrew for the same question.
If I could answer that kind of twice, if I may. So from my own specialist knowledge as an astronomer, it is once again information. It's about accurate orbits to know when things are going to pass over, publishing something a little better than the TLEs, but also three-dimensional structure of spacecraft. What happens as they rotate to try and predict glints. Then if I may be so bold as to step outside my own specialism, what worries me is developing some concrete sense of what the actual carrying capacity of low Earth orbit is and what that means. So a lot of people, for instance, Maura Bajar in Texas talk about this often, having a kind of the equivalent of a carbon footprint, but we don't know how to define that. So, and I think it will be quite hard to make progress on contested issues in LEO unless we have a real sense of what the real footprint of things is and what the carrying capacity of LEO is before you either interfere with each other in spectrum terms, statistically, or in other ways. So that's what I'd like to see, a bit of some concrete definitions that will enable us to make progress.
Thanks, Andrew. So yeah, I think it's an important point. Yes, what is the maximum carrying capacity of low Earth orbit or other orbits for that matter? Okay, and then yeah, we'll pass on to Derek.
Sorry about that. I was just getting unmuted. For myself, I think the most important thing is the collaboration in education, and that goes across everywhere. So we can see what the education of the environmental issues on the ground is happening with it just now, but we need to do that for up in the skies as well. And the collaboration, so that what I'm talking about is, I know I deal and speak with DINS quite a bit, and our company deals with them quite a bit because we believe we need to watch what we're launching into and what we're releasing. I know Professor Lawrence, I really take in what he says, especially about sort of the night sky and losing the night sky. It's not something we want to do. So I think we need to bring as many people to the table as possible so we can get that. The good thing about the Scottish space sector and the growing space sector in the UK is we're connected enough that we can have these discussions. So for me, it has to be that collaboration in education.
Thanks, Derek. So that brings us to 12 o'clock. So we're just at the end of the webinar. Just to wrap up, there's a question came through from Hugh Lewis, which we don't have time to go into, but I think it's very important for everyone maybe to take away from the webinar and to think about more. And that is, what does sustainable space actually look like in an ideal world? If we roll forward 5-10 years, what does sustainable space look like? I would imagine it's a world in which telecom, satellite operators, scientific users of space, astronomers, all can kind of happily coexist. And I guess that's our end goal for the long-term sustainability of space. So just to close, first let's just thank all our speakers for excellent and interesting and engaging presentations this morning. Thanks to all of the participants for joining the webinar, posting questions in the Q&A tab. And also thank you to our colleagues at the Catapult for setting up and organising the event this morning. The Emerging Technologies webinar programme, as Paul said, this is the third in a series, and please keep an eye out. We'll be running future emerging technologies webinars as we go into the future. So thanks again. Thanks for your time. Thanks for joining the event, and enjoy the rest of your day. I'll close there. Thank you.
Thank you, Colin. Thank you, everyone.